Welcome to FMA0146 Basic Mathematics. Today we're going to learn about the chapter 7, the last chapter in your basic mathematics, the application of differentiation. In chapter 7, we are going to cover the tangent and normal equation. Later on, you're going to learn about how to find how to solve the experiment problems. Later on, you're going to solve the application of the differentiation in economics and business, which is only the basic of the function, basic of the cost, price, revenue, and profit. Now, first at all, we're going to look at the tangent and the normal. What is a tangent? Tangent actually is the line which touches the curve, but at a particular point, and then after that, the derivation of this function will be the slope for the rate line or our tangent. And if we have a line who is a perpendicular to this red line, so this one is a perpendicular or 90 degree, so then it will become so the blue line is called a normal. So a normal to a curve is a line perpendicular to a tangent or to the curve. Over here, that is how do we finding the tangent equation. So first of all, what is a tangent? Tangent actually, excuse me, is just a straight line. So any straight line over here, that is, we are going to use the formula y minus y1. What is our y1? Y1 will be our the coordinate of y, and then this x is the coordinate of x. So y minus y1 equals to, and the slope of that particular straight line. So now, over here, that is, to find a tangent equation for a curve in a particular point means that over here the point is given. So what we need to do is we need to find the slope, or we call it as a gradient of the function. So in this chapter, you will learn how to use the differentiation to find the gradient. So it's very simple. You just need to do the first derivative for any function, then it will become the gradient for the function. After that, this particular dy dx is our slope, and then you substitute this n into the equation. So now, contrarily, that is, we have a normal equation. In this normal equation, the only difference that is we have a perpendicular. So from there over here, there is a theorem telling you that is, if two lines with the gradient of m1 and m2 are at the right angle, or we call it as a perpendicular or 90 degree, and then the multiplication of these two gradient equals to -1. This one is a theorem, so you just accept it. So from this one, m1, m2 equals to -1. So we will say that m1 actually is -1 over m2, or you can say that m2 actually equals to -1 over m1. So now, if I have to rephrase that here is, if I want to find a tangent and a normal at this particular point, the thing that is going to difference them is only the slope. So the point will not have any changes. Only will be having changes is only the slope. Okay, now we look at the first question that over here. Find the tangent of the function y equals to x cubed minus 5x squared at the point of this one. So first thing, what we need for forming a tangent is y minus y1 equals to mx minus x1. This one is a standard formula for any straight line. Okay, now I have my x1, I have my y1, so I can substitute here. My y1 is -7, my x1 is 3. Now what I'm lacking of is a slope. So from this y, I need to find the differentiation dy dx. So I will have 3x squared minus 10 minus 10 x plus 5. This one is a general slope for this equation. So if I want to have the slope or the gradient at this particular point, so I substitute my x with a 3. So 3 square minus 10, 3 plus 5. Actually, over here is 30. Sorry, this one is 27 minus 30 plus 5 is 2. So my gradient, okay, or my dy dx, when my x equals to 3, so my dy dx equals to 2, so I substitute here 2. And if we know that is any general of a straight line will be y equals to mx plus c, so what I need to do, I expand y plus 7, 2x minus 6, so finally y equals to 2x minus 13, so this one is our tangent. Okay, now we look at the example 2. Find the tangent of the function fx equals to ax cubed plus bx squared plus x plus 1, which is perpendicular to the line 2y plus x plus 1 equals to 0 at the point where x equals to negative 1. Hence, find the value of a and b. So this question or this problem telling you that this particular line is perpendicular. Okay, I have a slope, and then this line actually is a normal line. So because it said that it's perpendicular, so means that this one is a normal line, and this point is negative 1. Okay, now because we knowing that is by substituting, okay, so I have my normal, okay, I have my normal line is 2y plus x plus 1 equals to 0. So means when x equals to negative 1, so my 2y plus negative 1 plus 1 equals to 0, my y equals to 0. So I'm going to have my point over here actually is negative 1, 0. Okay, so now at the same, okay, after that, this is the first information. So I'm going to have a point negative 1, 0. Later on, from this normal also, I is going to provide me the slope. So 2y equals to negative 1, negative x negative 1. Y equals to negative 1 over 2x minus 1 over 2. From here, it's going to tell you that is your slope is negative 1 over 2 for this normal line. Because the information telling us that is n1 multiple n2 equals to is equals to negative 1. Means that a tangent multiplied with a normal is negative 1. So I just plug in my negative 1 over 2 into here. So my n1 is negative 1 over 2 equals to negative 1. My n1 actually is 2. From here, this one is my slope or the gradient of tangent. Okay, now actually whatever we can extract from this 2y plus x plus 1 is already finished. Now we look at this equation. It said that find the tangent for this one. Okay, so what you can do that is, now I already have my slope. Okay, so tangent equals to y minus y1 equals to m x minus x1. So my y minus 0 equals to my m is 2, x minus 1. So I'm going to have y equals to 2x plus 2 settled. So this one is my tangent line. Okay, now, because I already have my tangent line, the question asks me to find the value for my A and B. So how am I going to find the value for my A and B is, first, I can use the information of the slope. So f prime x equals to 3ax squared plus 2ax plus 1 must be equals to 2 when my f prime negative 1. So means that is 3a minus 2a, sorry, 3a minus, sorry, this is b, 3a minus 2b plus 1 equals to 2. So my 3a minus 2b must equals to 1. Okay, this is the first thing. And then the second thing is when my f equals to -1 must be equals to 0 because they are sharing the same point. Okay, now I substituting -1 inside my original equation. So I have my minus a plus b minus 1 plus 1 equals to 0. So now my minus a plus b equals to 0, or my a actually equals to b. So I can use this information substituting here inside here. 3a minus 2a equals to 1. So my a actually is 1 and my b equals to 1. So basically from here, that is from the others normal line, you can use back or revert information to find your fx. Now we look at the example 3. Find the point on the curve yx given by this one, where the tangents are parallel to the line y equals to x plus 5. It's almost about or less like the previous one. So from this information here, first thing, I'm going to find my m. My m over here is 1 because this one is y equals to mx plus c. So my m equals to 1. So over here is going to give me the same information because the tangent are parallel. Okay, so when they are parallel means that they're going to share the same gradient. So over here, dy dx equals to 3x squared minus 12x plus 1. So means my 3x squared minus 12x plus 1 must equals to 1 because these two must be having the same value. So I have 3x squared, sorry, my 12x. So this one is minus 12x equals to 0. 3x, excuse me, minus x minus 4 equals to 0. My x equals to 0 or my x equals to 4. When my x equals to 0, I substitute inside here, or you can be substitute. Okay, so you substituting into the original here. So my y actually equals to 3. And substituting 0 into here, 4 into here, my y will become negative 25. So which is the thing is I have two different value of my point. Example 4, find the equation of the tangent and the equation of the normal to the curve of this one and the point where your x equals to 2. So this one actually is quite straightforward. The only thing that is they asking for the tangent and the normal. So what you need to do is just find the differentiation, dy dx. Okay, so this one I bring the x become a power negative, x minus 1. So I'm going to have differentiate x actually is 1. Differentiate x minus 1 is minus x minus 2. And when my x equals to 2, dy dx equals to 1 minus, okay, this is 1x squared. So 1 minus 1 over 4 actually is 3 over 4. And this one is the gradient for my tangent. Okay, so y minus y1 equals to m x minus x1. So now my y, okay, m actually is 3 over 4. My x is, sorry, my x is 2. My minus 2. Okay, now what is my y1? So very easy. When x equals to 2, my y actually is 2 plus 1 over 2 actually is 5 is 5 over 2. So 5 over 2. If you check over here, if you want, actually you, as I say, our equation is always is y equals to ms plus c. So for the easy purpose, this one I cross over here. 2y minus 5, okay, equals to 6 over 4 x minus 2. So 2y minus 5. This one is 3. So you're going to have 3 over 2x minus with 3. So finally 2y equals to 3x over 2. And then you're going to have a plus 2. So if you want, you can bring over here is 4y equals to 3x plus 4. So this one is only the equation for your tangent. So you're going to do the same thing for your normal. Okay, so how to find the normal? Okay, normal is saying that is over here when my m1 multiple m2 equals to negative 1. Since my m1 is 3 over 4, multiple m2 actually is negative 1. So my m2 actually is negative 4 over 3. We are going to repeat this process again with the new n, which is y minus 5 over 2, negative 4 over 3, x minus 2. Okay, so now we are doing the same way. That is, you need to cross multiply everything, and then you will, by the end, you will get your answer as 6y plus 8x equals to 31. Okay, we go for the example 5. Given that the curve x squared plus y squared minus ln x squared plus ln y equals to 2, first thing they ask you to find dy dx at the negative 1 and 1. Okay, so what we need, very easy for us to do is, okay, we have an x squared plus y squared minus ln x squared. Or I can straight away write as this one as minus 2 ln x plus ln y equals to 2. And this one actually is an implicit equation. So what you do, just straight away differentiate 2x plus 2y dy dx minus 2 over x plus 1 over y dy dx, and don't forget differentiate 2 actually is 0. And because of the question said looking for dy dx at negative 1 1, you no need to rearrange everything. You just substitute the value negative 1 as an x and y as a y. So negative 2 plus 2 dy dx, and then this one will become plus 2. Y is become plus 2. Negative 2 over negative 1 actually is 2. And plus dy dx equals to 0. And if we look at here, we have a 3 dy dx equals to 0. And my dy dx actually equals to 0. And maybe we will start asking me, is it possible? Is it possible that is we have the equation, our differentiation is 0? Yes. Or our slope is 0. As you know, that is when my slope is 0, so this is the slope of 0. Okay, now, so that's why dy dx equals to 0. Okay, after that, it said that find an equation of the normal to the curve at a point negative 1 1. Okay, and maybe some of you already starting thinking f m1 m2 equals to negative 1. But m1, our m1 is 0. Multiple m2 equals to negative 1. And please don't say that m2 equals to negative 1 over 0. If you press your calculator, your calculator will tell you it's a max error. Okay, so now, what is actually when you have a slope is infinity? Means that I have a line who is perpendicular to this slope. So that's why this gradient is infinity. So now if I have a horizontal line, this one will become y equals to a. So in this line will become x equals to b. So at the point of negative 1, so the line of which is perpendicular to it is x actually is negative 1. Over here, there is no such thing asking you to form by using y equals to mx plus c. This one is more into the testing you, that is, what is the meaning of the horizontal, the perpendicular for a horizontal line. Now we look at the question 6. Given the curve xy equals to 4, find dy dx at 1, 1. Later on, they ask you to find an equation of the normal at x equals to 2. Find the x coordinate of the point where the normal line intersect the curve again. Okay, so now if I have a curve xy, we just follow the order saying that find dy dx. For this one, I refuse or I reluctantly to use implicit. So I can rewrite my equation as 4 equals to 4, y equals to 4 over x or 4x power of negative 1. So my dy dx actually is negative 4x negative 2. When my x equals to negative 1, over here is negative 1. So over here, my dy dx actually is negative 4. Okay, because anything negative power of 2 actually is 4. So my dy dx equals to 4. And then after that is find an equation, okay, of the normal to the curve at the point x equals to 2. Okay, now this one, there is no relationship with my dy dx as here. But the thing is, they're asking me to find at the point of 2. So I no need to calculate or re-differentiate of my dy dx. So I just straight away take this one, substitute my x equals to 2. So my dy dx will become negative 4 over 2 power of 2 actually is negative 1. And because of they are asking us for a normal, so my m1 multiple m2 is negative 1. Since my m1 is negative 1 divided negative 1 is 1. So my m2 equals to 1. So now from here, how am I going to solve the problem? When my x equals to 2, okay, I have xy equals to 4. So I will know that is my y actually equals to 2. And since the general formula y minus y1 equals to m, x minus x1, so y minus 2 equals to, remember, our m2 actually is 1, x minus 2. So I have y minus 2 equals to x minus 2, and my y actually equals to x. That's all. Find the x coordinate of the point where the normal intersect the curve again. Okay, so means that they are talking about this curve, this intercept again. So what you need to do is, so you just substitute the y because it's telling you y equals to x. So I just substitute y equals to x. So from the xy equals to 4, so I substitute my y equals to x. So x equals to 4. So x squared equals to 4. So my x actually is plus minus 2. But since x equals to 2 is already provided, so they're going to meet at x equals to negative 2. When x equals to negative 2, my y also negative 2. So the next x, oh sorry, they are only asking for x coordinate. So they are going to meet it again at x equals to negative 2. Now, the next example is find all the points on the graph of y equals to x cubed minus 3x where the tangent line is horizontal. Okay, what is horizontal? Over here they already say the tangent line is horizontal when the slope is equals to 0 or the gradient equals to 0. Okay, so now what we do is finding dy dx equals to 3x squared minus 3, and because of the tangent is horizontal equals to 0, so x squared minus 1 equals to 0. My x actually is plus minus 1. Okay, when my x equals to 1, so remember y equals to 1 minus 3, so it's negative 2. When my x equals to negative 1, my y actually is negative 1 plus 3 equals to 2. So my point is 1, negative 2, and negative 1, 2. So example, find the x and y intercept. Okay, what is y intercept or what is x intercept? X intercept when y equals to 0, or contrarily, the y intercept will be x equals to 0. For find the x and y intercept of the normal line to this one. So you have nothing to do. So first thing, we have y equals to x squared minus x. Okay, so dy dx equals to 2x minus 1. When my x equals to a, dy dx equals to 2a minus 1. Okay, and when my x equals to a, my y actually is a squared minus a. Okay, so y minus my 1 equals to mx minus x1. Okay, forgotten, this one is for the tangent, and the question is saying that normal. So normal, so my dy dx for the normal will become negative 1 over 2a minus 1. So now I have y minus a squared minus a equals to negative 1 over 2a minus 1, and then x minus a. Okay, so now this one actually is my normal line. Okay, this is my normal line. So now when over say that is when y intercept is x equals to 0. So now when x equals to 0, so I have y minus a squared plus a equals to negative 1 over 2a minus 1 minus a. So finally, my y, and we shifted this one to the other side. Okay, so if you want to know what is the x-intercept, so my y is equals to 0, and then you shift it to the other side, so you will have your y-intercept and x-intercept. I have to admit this example is quite of messy because the value is not that because it is an A, so when it is an A, so you cannot simplify, so it will be since that the answer is a bit messy. Okay, now so for this part I will stop here. Then the other part I will be continue and in my another video. Thank you.